So here we have the function log of 1 plus x divided by 3 raised to the power of x minus 1. So we have to find its limiting value when x approaches 0. What we're going to do is we will divide the numerator and the denominator by x. So that will give us limit x approaching 0. So we have log of 1 plus x divided by x whole divided by 3 raised to the power of x minus 1 divided by x. Now we know that this is the definition where limit x approaching 0 log of 1 plus x divided by x, the value is equals to 1, and limit x approaching 0 a raised to the power of x minus 1 divided by x is equals to the natural log of a. So let's use that. So the upper limit, that is upper limit in the sense, the limit for the numerator is going to be equals to 1, and the limit for the denominator is simply going to be the natural log of a. A here is 3, so we have 1 over log of 3. Let us do another problem. So we have a raised to the power of mx minus 1 in the numerator divided by a raised to the power of nx minus 1. So we need to determine the limiting value. So what we're going to do is divide the numerator by mx. So we're going to rewrite the numerator. So that will be a raised to the power of mx minus 1 divided by mx. Now m of x being an extra term that we're dividing, so we need to multiply by m of x. Similarly, in the denominator, we have a raised to the power of nx minus 1 divided by, so we're going to divide by nx and multiply by nx. So we can take care of the x. Mx divided by nx will be simply m over n. So m over n being a constant, we have taken it out. So now we have limit x tending to 0 a raised to the power of mx minus 1 divided by mx whole divided by limit x approaching 0 a raised to the power of nx minus 1 divided by nx. So that is going to give us m over n, the natural log of a divided by the natural log of a. So we're getting the same term in the numerator and the denominator. So our limiting value is going to be m over n. Let us do another problem. This problem is quite similar to the previous one, except that we have b in the denominator instead of a. So the computation will remain fairly the same. So we'll divide the numerator, which is a raised to the power of m of x minus 1 by mx, and we're going to multiply by mx. For the denominator part, we have b raised to the power of nx minus 1. So we're going to divide it by nx and multiply by nx. So we can take care of the x term, so it gets cancelled, and that leaves us with m over n limit x approaching 0. So we have a raised to the power of mx minus 1 all divided by mx, and for the denominator we have limit x approaching 0 b raised to the power of nx minus 1 divided by nx, and applying the definition of limit. So we have the natural log of a in the numerator and the natural log of b in the denominator. So this is going to be the limiting value of the given function when x approaches 0. Let us do another problem. So here we have to determine the exponential limit. The function is given by a raised to the power of mx minus b raised to the power of nx whole divided by x. So we begin by rewriting the numerator. So we need, in order to be able to apply the definition of limit, so we need a -1 here. Now this -1 being an extra term, so we need to add +1 to it. Similarly, we subtract 1 and add 1 to it, all divided by x. Now the numerator, we're going to arrange the terms, so we'll have a raised to the power of mx minus 1, so we're going to separate the 1, minus b raised to the power of nx minus 1, and we separate the positive 1, so positive 1 times -1 is going to give us -1, all divided by x. So we can now take care of this positive 1 and -1. Now separating the two terms in the numerator, so we'll have a raised to the power of mx minus 1 divided by x minus b raised to the power of nx minus 1 divided by x. Now, in order to be able to apply the definition of the exponential limit, we need an m times x in the denominator of the first function. So we do not have an m, so we simply multiply it by m, and also we need to divide by m. So that means simply multiplying the entire function by m. Similarly for the second term, so we needed nx in the denominator, so we multiply x with n and multiply the entire function by n. Now that is going to give us m times limit x approaching 0 a raised to the power of mx minus 1 divided by mx minus n multiplied to the limit x approaching 0 a raised to the power of nx minus 1 divided by nx. So this is finally going to give us m times the natural log of a minus n times the natural log of or here we have b, so it will be the natural log of b. Using the property of logarithm, the m is going to be the exponent of a. So we have log of the natural log of a raised to the power of m minus the natural log of b raised to the power of n. So here I have written log, so this is the natural log, which is equals to the natural log of a raised to the power of m divided by b raised to the power of n. So this is going to be the limiting value of the given exponential function when x approaches 0. So let me write it down. Here I have used the property that a log b is equals to log of b raised to the power of a. So this holds for natural logs as well, and the log of a minus log of b is equals to log of a over b. Okay, so let's move on to the next question. So in order to find the value of the given exponential limit, we'll rearrange the terms in the numerator. So we can rewrite it as limit x approaching 0, we have a raised to the power of x minus 1. So -3, this -3 can be written as -1 minus 1 minus 1. So we have taken one -1 and combined it with a raised to the power of x. Similarly, for the second term, we have b raised to the power of x minus 1 plus c raised to the power of x minus 1 divided by x. Now we can separate the three terms in the numerator and apply the limit to each of them. So I have a limit x approaching 0, a raised to the power of x minus 1 divided by x, plus limit x approaching 0, b raised to the power of x minus 1 divided by x, plus limit x approaching 0 divided by c raised to the power of x minus 1 divided by So the first limit will be the natural log of a plus the second limit, which is the natural log of b, and the third limit, which is the natural log of c. Now we're going to use the property. So we have log a plus log b plus log c. So that is going to be simply equals to the product of a, b, and c. So this is the limiting value of the given function when x approaches 0. Let's move on to the next question. Now this problem is similar to the previous one, except instead of a, b, and c, we have the values 5, 3, and 2 respectively. So in the previous question, we had limit x approaching 0, a raised to the power of x plus b raised to the power of x plus c raised to the power of x minus 3 whole divided by x, and it gave us log of a, b, and c. Now comparing it with this particular question, so our a will be equals to 5, b will be equals to 3, and c will be equals to 2. So that means the limiting value is going to be equals to log of 5 times 3 times 2. So 5 times 2 is 10, 10 times 3 is 30. So we'll get the natural log of 30. So this is going to be the limiting value of the given function when x approaches 0. Let's move on to the next question. Here we have the exponential function a raised to the power of 1 over x minus 1 whole multiplied to x. So we need to find its limiting value when x approaches an extremely large number. So what we can do, we can rewrite the entire function. So we have, this is infinity. So we have a raised to the power of 1 over x minus 1. Now we can take the x to the denominator. So that will become 1 over x. Now we assume that 1 over x be equals to y, such that when x approaches infinity, so that would mean y value will be 1 over infinity, which is 0, which implies that y is also approaching 0. So we have the limit y approaching 0, a raised to the power of y minus 1 divided by y. Now, this is the standard limit, so the value will be the natural log of a. Let's move on to the next question. So we can rewrite the given exponential function as limit x approaching 0, a raised to the power of x. So we can decompose -2 is -1 minus 1. So we're taking a -1 from -2, which leaves us with another -1 whole divided by x. So that will be limit x approaching 0, a raised to the power of x minus 1 divided by x plus limit x approaching 0, b raised to the power of x minus 1 divided by x. So we have natural log of a plus the natural log of b, which will be simply the natural log of the product of a and b. Let's do another. So here we have another exponential function. We need to find its limiting value when x approaches 0. So first we begin by factorizing the numerator. So we have limit x approaching 0. So 8 raised to the power of x can be written as 8 is 4 times 2. So that will be simply 4 raised to the power of x times 2 raised to the power of x. So we have 4 raised to the power of x times 2 raised to the power of x minus 4 raised to the power of x minus 2 raised to the power of x plus 1 whole divided by x squared. Now we're going to take 4 raised to the power of x as the common factor from the first two terms. So we'll be left with 2 raised to the power of x minus 1. Then taking -1 as the common factor, we'll be left with 2 raised to the power of x in the third term and minus 1 in the fourth term, whole divided by x squared. That will be equals to limit x approaching 0. So we have 2 raised to the power of x minus 1. multiplied to 4 raised to the power of x minus 1. Now we have x squared in the denominator, so we have x times x, which is simply x squared. Now applying the limit to each of the function, so we have log of 2 multiplied to the natural log of 4. So this is going to be the limiting value of our function when x approaches 0. Let's move on to the next question. So here we have another exponential function. We need to find its limiting value. So let us begin with the function. So we have f of x equals to a raised to the power of x plus a raised to the power of negative x minus 2 divided by x squared. So we have a raised to the power of x. So a raised to the power of negative x will be 1 over a raised to the power of x minus 2 divided by x squared, which will further give us a raised to the power of x whole squared plus 1 minus 2 times a raised to the power of x divided by a raised to the power of x times x squared. So this is an identity. So we have a squared plus a b squared minus 2ab. So that becomes a raised to the power of x minus 1 whole squared divided by a raised to the power of x times x squared. So now we can find out the limit. So we have limit x approaching 0, a raised to the power of x minus 1 divided by x. So this will be whole squared multiplied to 1 over a raised to the power of x. So when we apply the limits, so we have limit x approaching 0, a raised to the power of x minus 1 over x whole squared multiplied to limit x approaching 0, 1 over a raised to the power of x. So this is equals to, so we have the natural log of a whole squared multiplied to 1 over a raised to the power of x. So x is 0. So our final limiting value is natural log of a whole squared. Let's go to the next question. So we have another exponential function. So we need to determine its limit. So let's begin by working with the numerator. So we have a raised to the power of x. So we're going to subtract and add 1 to it. For b raised to the power of x, we're going to subtract 1 and add 1 to it, minus c raised to the power of x, subtract 1 and add 1. And finally for the fourth term, which is d raised to the power of x, subtract 1 and add 1 to it, all divided by x. So that's going to give us limit x approaching 0, a raised to the power of x minus 1 plus 1 plus b raised to the power of x minus 1 plus 1 minus c raised to the power of x minus 1 minus 1 minus d raised to the power of x minus 1 minus 1. So all the ones get cancelled out, and that leaves us with limit x approaching 0, a raised to the power of x minus 1 divided by x plus limit x approaching 0, b raised to the power of x minus 1 divided by x minus limit x approaching 0, c raised to the power of x minus 1 divided by x minus limit x approaching 0, d raised to the power of x minus 1 divided by x. So that's finally going to give us limit natural log of a plus natural log of b minus natural log of c minus natural log of d. So natural log of a plus natural log of b is going to be equals to natural log of a times b minus natural log of, so if we take negative as the common factor, so we have natural log of c plus natural log of d, which will be natural log of co times d. and the final value will be natural log of AB over CD.